Hi and welcome to wrist training. We're always going to do one exercise to stabilize the wrists. We're now going to read something what is written here to the hypothalamus and what it has to do with food intake and hunger and appetite. And participating in the exercises is at your own risk. Let's start with the first exercise for the wrists. Just have a go on a comfortable and stable stand and both hands, the fists comfortable next to you. And now we're bringing these fists down and again up. And if you feel by any of these exercises pain at the wrists, then stop immediately. So we're going slowly as far up as we can go up with a bit of effort. And as soon as you've reached the point which you could reach with a bit of effort, we're turning around and are going into the other direction. Just up as far as we can go and then back. And we never do any of these wrist exercises until exhaustion. So this is already the last time. So this was the first exercise. Let's look for the hypothalamus and what it has to do with the food intake or hunger and appetite. The hypothalamus is a circa 1 centimeter times 2 centimeter big part of the brain. The hypothalamus has many different functions. One of them is controlling of hunger and thirst. So the hypothalamus is around this size big, and it is inside of the brain. So the brain is not just one thing doing one thing, but there are different parts of it. And one of these parts is the hypothalamus, which is around this size. And it has many different functions, and one of these functions, which are important, of the hypothalamus is food, and this is about food. It's hunger and thirst. Before we go more in detail, the next exercise. Again, the hands comfortable at the side, and now we bring these hands to the inside and back to the outside. Again, same rules. All slowly and carefully and well thought through. And we're going only as far as we can go with a little bit of effort. And as soon as you've reached the point which you could reach with a little bit of effort, we're turning slowly around and are going into the other direction. If there's pain, we stop immediately. And we also stop before we reach exhaustion of the muscles and tendons of the wrists. So that this will be the last time that we're going to the outside and back to the inside. The hypothalamus is around this size in the brain. It has important functions. For example, it has to do with hunger and thirst. The hypothalamus has something called Ventromedial Nucleus. No further explanation, but with our hypothalamus has somewhere the Ventromedial Nucleus. Ventromedial Nucleus. Ventromedial Nucleus. When somewhere has the ventromedial nucleus of the hypothalamus an external lateral part. So there's also an external lateral part, but it's not a part, that is a region that is a directional indication. So somewhere on this part there is a top and back size in front and right and left size, and there is an external lateral part, wherever that is in the hypothalamus. Whatever, there is an external lateral part. And that's going to be important for the following things. For example, when this external lateral part of the ventromedial nucleus of the hypothalamus is stimulated, that causes, quote, increased food intake. So the source material says, but first the next exercise. We're having flat hands, no flat hands, and we bring these flat hands to the inside and to the outside. Back to the inside and to the outside. And we're going to do this now. One last time. And back to the inside. So increased food intake is just happening through stimulation of the external lateral part of the ventromedial nucleus of the hypothalamus. I guess not. It just increases hunger, and that hunger can lead to increased food intake. But okay. If the external lateral part of the ventromedial nucleus of the hypothalamus is damaged, that causes, quote, complete cessation of food intake. So, if it is stimulated, that external lateral part, wherever that is, if it's in front and back and top and down or in the inside, wherever that external lateral part is, then if it's stimulated, more food is eaten, or I guess should be eaten. Maybe there is no food and food can't be eaten. Hunger increases. And if If it's damaged, so not stimulated, but damaged with this external lateral part of the ventromedial nucleus of the hypothalamus, then food is cessated to eat, so hunger decreases. It mentions even completely. The next exercise, the pancake flip. We're having flat hands next to us, and we're lifting these hands up to the sky and again down to the ground. And it's slowly controlled, concentrated. Up again and down. And that's gonna be our last time. Up to the sky and down to the ground. So, stimulation of the external lateral part of the ventromedial nucleus part of the hypothalamus increases hunger, and damage to the external lateral part of the ventromedial nucleus of the hypothalamus decreases hunger. Had we anything before that one was important? Not really. It's included in it. So, if the medial part of the ventromedial nucleus is damaged, hyperphagia is caused. And hyperphagia, we have an explanation, is an abnormal strong sensation of hunger. Hyperphagia. Hyperphagia is an abnormal strong sensation of hunger. Hyperphagia, if the medial part is damaged. If the medial part of the ventromedial nucleus is damaged, then it leads to an abnormal sensation of hunger. We are bringing the next exercise. Both hands are out with flat hands, and we bring these flat hands down. And again up. And again down. And again up. And this is the last time. Up again. Resource material lists 4 hypotheses to the hunger and thirst aspects of the hypothalamus. First hypothesis. Lipostatic hypothesis. It says that adipose tissue produces a so-called humoral signal, which is in proportion to the amount of adipose tissue and acts on the hypothalamus to decrease food intake. So, the more adipose tissue, so the more fat in the human body is, the more of a humor signal is produced. So if there's only a little bit fat in the human body, then only a little bit of humor signal is produced, and the hypothalamus still wants more to eat. And if there's a lot of adipose tissue, this adipose tissue is more and can produce more of this humoral signal, and the hypothalamus is being told that it should stop eating. That is the lipostatic hypothesis. Lipostatic hypothesis. The next exercise. Now, the T-Rex. That was the T-Rex in the morning. The last exercise. Now the T-Rex is in the gym. If you don't have a tennis ball, do it without one. I'm taking a tennis ball like this. Just a flat hand, and we are pressing onto the tennis ball, moderate force, and releasing again. And we are pressing again, and releasing. And last time, we are pressing and releasing, and we're switching with the other hand now, pressing onto the tennis ball, and releasing, pressing again, and releasing. And the last time, pressing with moderate force and releasing. Now to the cautious Big Bang. We're placing the hands of one hand on top of the fingernails of the other hand. Now we're opening against that pressing hand. Now we're closing slowly against that pressing hand, which otherwise would make the cautious Big Bang close faster. And for the last time, and now it's time that the positions are switched, and we are opening again and closing that hand presses the whole time. The last time. That was the cautious Big Bang. So the lipostatic hypothesis says the more adipositous tissue there is, the more humoral signal is produced and tells the hypothalamus to stop eating. Stop to produce a hunger feeling. Second theory, gut appetite hypothesis. Food entering the gastrointestinal tract triggers the release of CK, which acts on the brain that it should produce satiety. Satiety is the feeling of that it's enough eaten. So, food entering the gastrointestinal tract triggers CCK, telling the brain to stop eating. The next exercise, it is this one. We're having the hands at the outside, and we're bringing the hands down, and we're flaring the fingers. Now we're bringing the hands again up, and we're making a strong fist, so we're pressing the fist a bit together. And now switching it. The hands down, the flared fingers, and bring the hands again up, and press the fist a bit together, and down and flare the fingers from last time, and up again, and make a strong fist. Lipostatic hypothesis, the more adipose this tissue, the more humor signal to tell the hypothalamus to stop eating. Good pitted gut-diet hypothesis, food entering the gastrointestinal tract, telling the brain to, through CCK, to stop eating, and to give a feeling of satiety. And third one, glucostatic hypothesis, when the glucose utilization of the neurons at the satiety center of the ventromedial nucleus is low. We don't have time really for it, I think. And consequently, the arteriovenous blood glucose difference across the neurons and the satiety center of the ventromedial nucleus, the activity across the neurons decreases. If the glucose utilization and the arteriovenous blood glucose difference across the neurons and the satiety center of the ventromedial. So if the glucose utilizations between the neurons and the satiety center of the ventromedial nuclei is slower, the person feels hunger because the feeding center is unchecked. So that means, I guess, that the person doesn't know it has eaten because the glucose utilization between the neurons and the nuclei in the ventromedial nuclei is unchecked, is too low, the glucose utilization, and they don't know that they have eaten and the hunger is still there. And the fourth one, the last one, thermostatic hypothesis. Decrease of body temperature below a certain point stimulates appetite. Increase of body temperature above a certain point inhibits appetite. Inhibit means lowers. So if it decreases under a certain point, hunger is there. If it is over a certain point, hunger is gone. Next exercise, the quadrangular castle-like attack. Both hands with fists out, and we bring his fists to the inside. And we're bringing them up and to the outside and down. And they are facing each other, and now down to the outside, and up, and it's the end of this exercise. The grab anxious to the finger, we arm at the outside, the hand goes down and we're pressing against the index finger. And from the outside, from the top, from the bottom. Now the same. The other hand, fist down, and press from the outside. Pull from the outside, and press from the top, and from the bottom. And we're done with all the exercises, a relaxation exercise for the extended jaw. You flex the wrist and you bend the elbow. And now you make a fist, you flex the wrist, and you straighten the arm. So again, hands out, now make a fist and bring the hands in and up. So hands goes from this to this, the arm from bend to open. You go with the thumb over the middle part here. From here to here, there's the extended toe. This hand fisted in and arm long. And the last time, this one with the other hand. Fist straighten the arm. And last time. So the lipostatic hypothesis, the more adipositous tissue and the more humoral signal to stop eating to the hypothalamus. The glutopated hypothesis, food entering the gastrointestinal tract, giving CCK to the brain and telling to stop eating. The thermostatic is the fourth thermostatic hypothesis. If the body temperature is below a certain point, hunger is there. If it's above a certain point, hunger is gone. And the third one was the glucostatic hypothesis. If the glucose utilization between the neurons and the ventromedial nuclei is too low, and so it never is told to the brain that it was eaten, if I have it correctly. And then the other things were, if the external lateral part of the ventromedial nucleus is stimulated, hunger is there. If the external lateral part of the ventromedial nucleus is damaged, hunger is gone. if the medial part is damaged when Hyperphagia. If the medial part of the ventromedial nucleus of the hypothalamus is damaged, hyperphagia is bad. Hyperphagia is an abnormal big sensation of hunger. I thank you very much for your time, and until next time.